just like in the other two sections, since computer output is so important to us, that's where a lot of our work is going to come from. So you'll have on your exams and such sometimes pre-given computer outputs, so we need to know how to read them. So having wide disparities from state to state in the number of poor children is a concern for many lawmakers, charity groups, and more. In 2008, the Annie E. Casey Foundation released a study stating that the variability, i.e. the standard deviation, in the number of children per state in poverty was 350,000. A researcher found for the foundation is going to test this value and gathers information on the number of children in poverty in a random group of states from the most recent U.S. Census. The data comes from a population that is normally distributed. Oh, that's nice to know ahead of time. Good. Okay, so the hypothesis test outputs for 2 computer programs are below. Use those to answer the questions. And again, I can just give you these outputs and you can use them to actually run the whole test. You could step 1, step 2, and so on. I've broken it down into pieces here. Okay, so what type of test did this researcher perform? So if we look at it, we can see that they're picking a right-tailed because they have a greater than symbol in their alternative hypotheses. So it's a right-tailed test. All right, what parameter is StatCrunch testing? All right, StatCrunch is this output up here, one we are more familiar with. And you can see that it's testing sigma squared, which is the variance of that variable. So it's testing sigma squared. So the null hypothesis and alternative hypotheses in symbol form for the StatCrunch program are sigma squared equals 122,500, and sigma squared is greater than 122,500, right there. That's the null and alternative. All right, what about Minitab? Minitab is testing sigma, plain sigma. Minitab can also test sigma squared, but it didn't in this instance, right? So sigma, plain sigma, 350, greater than 50. At least I think it can. I vaguely remember that. But anyway, for right now it's testing sigma, right? Which means that the null and alternative hypotheses are these 2 values. Sigma equals 350, sigma is greater than 350. All right, why is the output different? Why is the output different? That's a typo. Between StatCrunch and Minitab, no big deal. Oh, I guess it is. The output difference between StatCrunch and Minitab, no big deal. So StatCrunch uses the variance, but Minitab uses the standard deviation. But it's okay because that standard deviation, 350 squared, is 122,500. So both programs are really doing the same test. It just doesn't look like it's the same test originally. All right, how many states were sampled? Looks like 8. N is 8 right here. Down here you can see the degrees of freedom is 7, which means n must have been 8, right? Because remember, degrees of freedom is n minus 1. So n is equal to 8, degrees of freedom is equal to 7, we just saw that. The standard deviation was, here you can see it's 585, and here they didn't give it to you. They gave you the variance, so you could take the square root of that with your calculator or Excel to find the standard deviation. So it should be around 585. The variance is 341,845, which, let's see, it's given right here in Minitab, 341,845, 341,845, and StatCrunch right there. Again, StatCrunch didn't give sigma, though, or excuse me, s, so we'd have to take the square root of that to find the standard deviation. Alrighty. What was the test statistic? That's chi-naught squared, which is 19.53. You can see it right here. That's in Minitab. And in StatCrunch, it's right here, the chi-square stat, 19.53. Let me circle those. Hold on. There we go. I just wanted to give those a little green ring. So the chi-square statistic is in that green ring, 19.53. So that's your test statistic. And the p-value, which is what's coming next is 0.007. So that's the blue ring right there, rectangle. So that's the p-value, or right there, 0.007. That's the p-value. All right, so use the computer output to perform step 4 of the p-value method. So you would draw a chi-square distribution. Yes, you have to draw that by hand. And then you put down your chi-square stat, which was 19.53. It was given to you right there, 19.53. And then since this was a right-tailed test, we're only doing that little part. And then we assign the p-value to it, which was 0.007. Minitab here is giving us a little bit more than we asked for, but that's okay. So that's step 4, draw a picture, shade it appropriately, label, put your chi-square stat in, put your p-value in. If the researchers set alpha to be 0.05, would the results be statistically significant? And the answer is yes, for sure, because that p-value is less than alpha, right? P equals 0.007 is less than your alpha value. We would reject the null hypothesis, and that means statistically significant. Don't forget, ever, that rejecting the null hypothesis is called significant, and not rejecting the null hypothesis is not significant. If the researchers set alpha to 0.05, what conclusion would be reached? So there would be sufficient evidence to support the claim that the variability in the number of children per state living in poverty is greater than 350,000. And I just wanted to make a note of why would that be important. Well, you can imagine that if you're trying to allocate resources from state to state and you have a lot of variability, it means that, treating all the states like they're equal might not actually work out well for you, because some states have a lot of kids in poverty, some states have lesser kids in poverty, just due to population differences, if nothing else. So that variability can really affect how you allocate resources, say for the Red Cross or for the Salvation Army, that kind of thing. All right, we're done with this section, section 10.4. It was kind of the same as the others. And now we're going to meet back here just for a one video recap of everything we've learned in chapter 10. See you then.